Hello dear friends, welcome to GATE Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. The student who have attended my last class, they would have a little bit idea the different kinds of the numericals which we were taking in last 2 days. Specifically in last day or the previous day, we were taking the numericals based on the concept of the permutation and combinations which can be used within the probability itself. So the number of questions which we have taken in the last class, this were the question. The 7 number of balls we had, out of them the 3 number of black balls we had, 2 number of blue balls we had and 2 number of red balls we had. And now we were trying to withdraw the 2 number of balls, and as I was communicating in the last class, if you are going to select 2 or 3 or maybe 4 number of items from any given set of maybe urn, maybe set of box, there are 3 different ways through which you could have selected those items. First, together. That means all of the R number of items has been selected together. That's the first kind of the problem. And the second kind of the problem in succession, and that too without replacement. That means we are picking one ball out or one item out and we are just throwing it out. We are not keeping it back. And again the second item or the second ball has been taken out. Again it has been thrown it out. So may I know how many ways this has been made? The 3 different ways. First, together. That means all of the items has been collected together. Second, in succession without replacement. That means we are collecting one by another and we are not making it replaced. We are not making it replaced. And similarly, the third case was with replacement. That means we are picking one ball out and again we are putting it back. Again we are putting it back. Anyways, the type of questions which we have taken in the last video was precisely written over here. See what it's been. If 2 balls are withdrawn simultaneously, then find the probability. That means the kind of the questions which we were taking in the last class was very precise, that both of the balls has been withdrawn simultaneously. Anyways, we went into the detailed analysis. If this sort of problem do come, how do we deal with those sort of problems? We have already seen in the last class. So anyways, let me go ahead with the second kind of the problem. Almost the structure of the problem remains very same. Still you have got the 7 number of balls as you had earlier. Still you had the 3 number of black balls, 2 number of blue balls and 2 number of red balls. Almost the structure of the problem or the number of balls you had, the varieties of the balls you had, they all are pretty same. Still you are withdrawing the 2 number of balls, but the methodology of the withdrawal has got changed. Still you are withdrawing the 2 number of balls, but it's not simultaneously. You are withdrawing in succession one after another. Even in succession or one after another can also be bifurcated in 2 parts, with replacement and without replacement. And this problem has been the problem without replacement. That means whatever the ball has been picked out, you had to throw it out, you don't have to bring it back, and again you had to pull one ball out. So may I know what had been the methodology? For the better understanding, let me go over the digital board once. The 7 number of balls you have, 7 number of balls you had, you are going to withdraw the 1 ball and you are not keeping it back. You have just observed this color and then you have discarded it. You have discarded it. And again you had put your hand inside and again we have withdrawn another ball. So this has been the problem. One after another. It's also called in succession without replacement. The replacement is not being made, without replacement. So the second segment of the problem which we are going to take in today's class would be based on withdrawal without replacement. Whenever it's been said withdrawal without replacement, that means we are withdrawing the ball one after another. We have been withdrawing the ball one after another. So till this point I don't find any of the student would have any sort of doubt. But the answers which we were getting is completely different. If you will focus over the problem or the set of the problem which we have taken earlier, we had the 7 number of balls. Here also we had the 7 number of balls. 3 number of black balls we had, 3 number of blacks now ball we are also having now also. 2 number of blue balls we had, now also we are going to have the 2 number of blue balls and including the 2 number of red balls. Everything is very perfect. Even we are withdrawing the 2 number of balls. There also we are going to be withdrawing the 2 number of balls, but the method of withdrawal has got changed. Here both of the balls has been withdrawn simultaneously, but there it would be withdrawal in succession one after another, and that too without replacement. That's the first thing. And once you go into the first question, within this question both are the black. There also the 8th question which we are going to take in today's class, there also we wanted to have a situation where both has to be black. Everything is very same. Everything is very same except the methodology. You can see very well. If two balls are withdrawn in succession without replacement, then find the probability. Both are black. Both are black. Tell me, what would be its answer? What would be its answer? What would be its answer? Here comes the first question. How many number of balls you had? If you want, I can mark it over here. The 7 number of balls we had, sir. Out of them, the number of black balls were 3, sir. The number of red ball were 2, sir. And the number of blue balls were 2, sir. From here onwards, the black ball, I would be referring it by capital B. Red ball, I would be referring by capital R. And the blue ball, I would be referring it by capital B, small l. Small l. And the method of withdrawal had been withdrawal in succession. That means one after another. It has not been once together without replacement. That means once we saw one ball, we are just going to discard it out. We are just going to discard it out. May I know, both are black. How it's possible? How it's possible? You just had put your hand inside this well shuffled maybe urn or maybe box, and you have withdrawn one ball. And as we wanted to have both as a black ball, so obviously we are in search of finding the probability that the first ball which has been taken out had been black. May I know what would be its probability? How many black balls you had? 3 black balls you had. Among them, you are going to withdraw one black ball out of the 7 number of balls. Obviously, it's going to be 7C1. And as we had to satisfy that the both of the withdrawal ball has to be black, that means the first ball has to be black, even the second ball should also be black. What it says, the first ball has to be black and the second ball should also be black. And whenever the and do come into the picture, we used to take the multiplication in mathematics, specifically in probability. May I know, if one ball has been taken out, that has been black, and if it has been thrown it out, how many number of balls has been left out? Earlier it was 7, but now it has been reduced to 6. And out of 6 number of ball, again one more ball has to be taken out, and that ball should come from the set of black balls. May you know how many number of black balls we had? Already one black ball has been taken out and it has been thrown it out. So number of black balls which has been left in my bag has been only 2. And I wanted to retrieve one black out of 2 blacks. Out of 2 blacks. Could you understand what I am saying? So till this point, I don't find any of the student would have any sort of doubt. Should I be repeating once again? The methodology which we were following in the last class and the type of questions we have framed in today's lecture is a bit different. In last class, both of the balls has been withdrawal simultaneously, but here we are withdrawing one after another in succession, and that too without replacement. As it has been a case of without replacement, that is why if one ball has been taken out, the total number of balls has been reduced from 7 to 6, and at the same time, as that ball has been taken out from the black, the number of black balls has been reduced to 3 to 2. So till this point, I don't find any of the student would have any sort of conceptual distress. 3C1, it has been communicated probably 3 days back. Whenever you deal with the NC1, the result would always be N. So here comes 3. That means the 3 way you could have retrieved the number of black balls. And similarly, 7C1 remains 7 as we had in case of 3C1. And here becomes 2C1, it's going to be 2. And here it's going to be 6 put together. What is happening over here? 2 and 3. 2 and 6 had a common factor as 3, so obviously 3 would be left out, and even 3 and 3 would go out, and probably the answer which we are supposed to get, it's going to be 1 upon 7. It's going to be 1 upon 7. Agreed? Should I be repeating once again? We wanted to have black in the first withdraw. We wanted to have the black in second withdraw. How it's possible? Out of 7 number of ball, you are going to select one ball. How many ways it can be done? Obviously 7 different ways it can be done. Either you are selecting the first, second, third, first black ball, second black ball, third black ball, first red ball, second red ball, first blue ball and second blue ball. So how many ways it could have been done? The 7 different ways it could have been done. But here you are strictly wanted to withdraw that ball from the black. How many ways it could have been done? Either you could have withdrawn the first ball, either you could have withdrawn the second ball, either you could have withdrawn the third ball. How many ways it could have been done? 3C1, and 3C1 is nothing but 3. And now it has been discarded. Without replacement, the case has been. And if it is being discarded, may I know what would be the structure of this box now? The number of balls earlier were 7, now has been reduced to 6. That's the first thing. And may I know where the major reduction had come? That reduction had come from the black. So the number of black balls which has been left out is precisely 2. So now again I want a black ball. Why this multiplication have come? Because as per my requirement, I want the first ball as a black ball and the second ball as a black ball. Wherever the and do come into the picture, by default I take the multiplication. So now the number of black balls which have been left out, already one ball has been discarded, that has been a black ball. So out of 2 number of black ball, how many way one ball can be picked, can be selected, can be withdrawn? So it's going to be 2C1, 6C1. End of the day, the result which we are supposed to get after solving this complete problem had been 1 upon 7. Had been 1 upon 7 or 21 it's coming. Yes, so here it's going to be, okay. That is fine. 1 upon 7 it's coming. Similarly, in the same sequence, let me move forward with the second question. If the methodology is clear, probably you would be able to smash the remaining 4 to 5 number of problems which are based on the same sort of withdrawal that has been one after another without replacement. Both are red. May I know what should be the answer for this? I want the first ball to be red and the second ball to be red. How the first ball would be red? Out of 7 number of ball, we are going to select the 1 ball. That's fine, sir. And how many number of red ball we had? The 2 number of red ball we had. So out of 2 number of red ball, we are going to select 1 red ball. And now if you have selected that red ball, and this has been the case of without replacement, so obviously that red ball has to get discarded. And as the red ball has got discarded, the number of balls which has been left out within your box has been reduced to 6. Again, you are going to withdraw 1 ball out of it. And how many red balls have been left out? Only 1 red ball has been left out. And once you multiply this factor together, 2C1 would stand for 2, 7C1 would stand for 7, 1C1 would stand for 1, and 6C1 would stand for 6. Put together, the 2 and 6 is going to get off. The factor which would be left out is going to be 3. The 3 would get multiplied with the 7, and here it became 1 upon 21. So you can see the probability that the both of the ball would be red is lesser in probability in compare with black, because the number of black balls were more. Number of black balls were more. In the same sequence, let me take the next question. Here comes the next question. Yeah. And I know many of these students do the mistake over this sort of problem. Try to read this problem carefully and try to decode what exactly they wanted to ask from you. 1 black and 1 red ball. My dear friends, this could have been done into the 2 different ways. We wanted to have 1 ball as a black and 1 ball as a red. The sequence could have been, if I have picked 1 ball out, that ball has been found to be black. And if again I have put my hand inside a bag and the another ball has been red, be black and red. Or whenever the or do come, obviously addition would come. Whenever I have put in my first hand, that ball had been red itself. The ball had been red itself, and now again I am putting my hand back, and now the ball had been black. So you had to consider both of the patterns. So obviously the sequence do also matter in this case. Should I be repeating once again? The sequence do also matter in this case. 1 black and 1 red. Here it has not been clearly said that the first ball has to be a red or whether the first ball has to be a black. If the first ball has been a red, the second ball has to be a black. That's well and good. And if the first ball has been a black, the second ball has to be a red. That means both of the sequences has to be covered while taking its probability. May I know how it would get calculated? The first ball has to be a black ball. How many black balls you had, my dear friends? The 3 number of black balls you had. How many ways they could have been selected? Unnecessarily you are writing 3C1, 3C1, 3C1 again and again. If you have the 3 number of item and if you are selecting only 1 item out of 3, how many ways it could have been done? You could have selected the first one, you could have selected the second one, you could have selected the third one. How many ways it could have been done? It could have been done simply by 3 different ways. Either you could have written this as a 3C1, but unnecessarily we are repeatedly writing 3C1, 261, 5C1, and we are landing to the same value. So now it's the right time to reduce your effort. Now it's right time to reduce your complete process and try to get the answer at the as early as possible. Agreed what I'm saying? So rather writing it 3C1, 7C1, 2C1, 6C1, I would suggest to each one of you have this practice. Similarly, to a denominator side, again you have been picking one ball out of 7 number of balls. How many ways it could have been done? It's just simply equals to of 7 times into. Now the ball which has been picked out has been a black, and that has been discarded. So the total number of balls which has been left out within your box has been 6 only. May I know how many number of red ball had been there? My dear friends, the reduction has been taken place in black, but there is still the number of red ball had been 2 only. So here is going to be 2C1. That would be 2 only. In the same sequence, if you go ahead, or if the first ball which has been withdrawn, if it is found to be red, may I know what would be its probability? How many red number of balls you had? 2 number of red balls you had, and how many ways it could have been selected if the one item had been withdrawn? So it's going to be 2C1. And similarly, total how many ways the one ball could have been selected out of 7 number of balls? They could have been 7C1, or simply I can write this as a 7 itself. Whenever the AND come, by default the mathematical operation multiplication do come, and now we are in search that the second ball has to be black. We are in search that the second ball has to be black. Already one ball which has been a red has been discarded, so the total number of balls which has been left out within the box has been 6. We are in search of one black to be taken out. How many ways the total balls could have been withdrawn? 6C1. And now we are in search of black. How many black balls has been left out? 3C1. Still it is 3. Still it is 3. Manju, the AND has to be taken. You just understand in this, my friends. It has been clearly said, as per your requirement, one ball has to be black and another ball has to be red. So orally speaking, when you speak in English, you can't say no, one black ball or one red ball. You want the situation that strictly there must be a one black ball and strictly there must be a red ball. So there the composition which you can use in between, it can't be or no, it has to be AND. So I am saying in first trial, or the first way of expressing the complete problem could have been, first has been the black ball and the second had been the red ball. Obviously it is satisfying my requirement, or I could have the different way to bring the balls out. The first was a red ball and the second was a black ball. So obviously, while you speak this complete proposition, while you speak this complete problem, definitely you would be bringing AND over here, and you would be bringing OR over here, and wherever the AND do come into the picture, by default you are going to multiply, and whenever OR do come into the picture, by default you are going to add them. You are going to add them. Yes, and one of the best thing, did you notice or not? These values are always gonna be same. Why? See, first focus over the denominator. At very beginning, it had 7. Because one ball was selected out of 7, still it has been 7. Here also it's been 7. Second trial, now the number of ball has been reduced from 7 to 6. So obviously it became 6C1, and here also it's 6C1. So as far as the denominator is being concerned, they would always be same. And if you'll talk about its numerator, no, the numerator is also not being changed. See, at very beginning I was in search of black and then red. So here it was 3C1 and here it was 2C1. Now the sequence has got changed. That means the sequence of the digit which were there towards the numerator side during its multiplication got changed. Here it was 3 then 2, now it became 2 to 3. 2 to 3. So whenever this sort of problem do come into the picture now, I would request to all of you, just calculate the first factor, and once you are done with the first factor, just multiply with 2. That's it. So here it becomes 3 divided by 7. 3 divided by 7, it's getting multiplied with a 2 divided by 6. 2 divided by 6. So obviously 2 into 3, that's a 6, and put together the result which we are getting out of it, it's going to be 2 divided by 7. It's going to be 2 divided by 7. Could you understand what I'm saying? If you want to write this important factor which I have just explained over here, because unnecessarily you are wasting your time. Could you really understood what are the different points where you are wasting your time? The first point, again and again you are writing 3C1, 2C1, 5C1, 7C1, 8C1. My dear friends, NC1 is always equals to of n, rather writing C, 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 again, just focus over that value itself. That is why rather writing in terms of combination, I straight away hopped into the numeric value which we would be getting after doing all of the jugglery calculations. That's the first thing. And whenever you do come across this sort of problem, this value and this value would always be same. I would show few more number of problems. You'll be happily able to understand that whatever the sir is wanted to communicate, it's precisely correct. So rather calculating this and this term isolately, just focus over their formation. Towards denominator side, there is no change. Towards the numerator side, there had only be change in their order. And as far as the multiplication is concerned, either you write A into B, either you write B into A. Hardly it makes sense. Hardly it makes sense. 2 divided by 7. 2 divided by 7. This has been the answer of 1.2.3. 1.2.3. May I know till this point each and everything is clear or not? If it is clear, I am just going to rub this out and we would go into the next kind of the problem that has been 1.2.4, and then we would go for the 5 as well as 6. If this part is clear, just write clear over the live chat. So I am just going to rub this all calculations which we have carried out today, and then we would move forward with the next question. We would move forward for the next question. Whenever I ask anything, no, be prompt while replying over the live chat, because we are just going to spend 1 hour. I don't want to waste your time. Yes, is that part clear? Clear. Pooja Reddy says clear, sir. Subhangi says clear, sir. That's fine. That's fine. Okay, okay, okay. So now it's the right time. It's the right time to discuss about the next problem, and that had been 1.2.4. As per the problem, we wanted to have a situation where none of them has to be black. None of them has to be a black. Anyways, before getting its perfect answer, no, you should have the clear-cut idea which are the different scenarios, which are the different situations would come under this. I don't want any of the ball has to be black. What are the different situations you can have? Both could be red. The first situation, both could be red. That's fine, sir. Both could be blue. That is also a permissible situation because the black has not been involved in either of the case. Third situation could be the first one was red and the second was blue, and the next situation was the first withdrawal was black and the second withdrawal was red. If you are leaving any of the situation, any of the scenario, you would be getting the wrong answer. You would be getting the wrong answer. Should I be repeating once again? The first ball which was withdrawal, sir, it was red. It was discarded, and the second ball which was withdrawal, that is also red. Whether it is satisfying the requirement of this or not, definitely it's satisfying the requirement of this, because neither the first, neither the second withdrawal had the color as black. Red and red, whenever the and do come, by default we would take the multiplication while doing its mathematical analysis. Similarly, or, as the or do come, obviously the plus sign would be taken in between. I want both to be black. How it's possible? Black and black, obviously again the multiplication sign would come in between. Or I want alternatively one to be red and one to be black. Here the point, make it clear, the sequence would be taken as the two different outcomes. The first is red and black or black and red. Why? Because both of the balls are not taken together. They have been taken one after another. So whether you have withdrawn the blue first or whether you have withdrawn the red first, they are going to make the two different scenarios. So I know this is the point where major of the students do mistake. What they would write, they would just go ahead with the red and blue and they would not be considering blue and red. Yes, that's a different story together. When we were withdrawing both of the balls together, there it does not make any sense that the blue has been withdrawn first or whether the red has been withdrawn first, because both of them has been withdrawn together. Both of them has been withdrawn together. Agreed, no? So till this point, I don't find any of the student would have any sort of doubt now. So 4 different outcomes you are going to have. And before going to do the mathematical calculation over this complete expression, just focus over the R and blue and blue. The number of red balls were 2, the number of blue balls were 2. That means here I would be having 2C1, anyways it's a 2 divided by 7 into 2 divided by 7. And here with the blue also the same situation occurs, because still the number of blue balls which we had within our blocks had been 2. So here also it's going to be 2 divided by 7 and here is going to be 1 divided by 7. So you should reduce your calculation as you proceed further. At very beginning, when you are at learning stage, you need not to do any hurry and worry. Try to do each and individual calculation such that you would be more than acquainted with each and individual steps, each and individual points where you can do mistake. But once you are done or once you have reached to the moderate level, no, try to improve your problem solving skill and try to reduce your number of steps. At very beginning you need not to do that, but once you come into the middle level, no, you should start doing that. Could you understand what I'm saying? So may I know, would it have the same value? Would it have the different value? No doubt, sir, they would have the same value, because the number of red ball, number of blue balls which we had in at least this problem had been same. So it would be 2 into 1 divided by of 7 into 6. And the same thing is going to happen over here. So as both of the terms had been same, once they would get added, the 2 would get multiplied. 2 would get multiplied. In the same sequence, let me focus over here. May I know the worth which would be calculated by this and the worth which would be calculated by this? Would it be same or would it be different? Which we have already seen, sir. Denominator would be in same sequence. The first component would be 7 towards the denominator side. The second component would be 6 towards the denominator side. As far as the numerator is concerned, their sequence would get changed. But as far as multiplication is concerned, if their sequence is also getting changed, still the impact, the worth towards numerator would not change. So just focus over the red and then blue. May you know how many number of red balls you had? 2 red balls you had. You wanted to select one out of them. How many ways you could have done? You could have done in the 2 different ways. Towards denominator, total 7 number of balls we had. How many ways one ball could have been selected? 7 ways. And here goes. Now my dear friends, I am not willing to select the red ball, I am willing to select the blue ball, although the red ball has been picked out and has been thrown it out. So the number of balls which has been left out has been only 6. But may I know whether any reduction over the blue ball? No, sir. The reduction were there over the red ball. So still it would be 2. It would be 2. And here also the 2 has to get multiplied. May I know what would be the worth over here? You can calculate this answer by yourself. 2 can be taken common and probably you would be able to get this answer easily. How much answer you are getting? You can do it by yourself. If you want, I can do it for you guys. See what is happening over here. See what are the component had been common. Whenever you do the calculation, try to extract all of the common terms. Like 2 had been common here as well as here. 2 had been common here as well as here. So anyways, one more 2 had been come out. And towards denominator side, we had 7 into 6 which were common. Obviously, sir, it's simply going to be 7 into 6. So the terms which has been left out with the first expression, see, that has been only 1. And here the 2 has been taken out, 2 has been taken out, 7 has been taken out, 6 has been taken out. The term which has been left out is simply going to be 1 plus of 2. 1 plus of 2. So what is happening over here? 1 plus of 2, that's going to be 3. 3 can smash the 6. The 2 would be the component which we left out. The 2 and 2 is also going to get out. And so the factor which is going to get left out is simply going to be 2 divided by 7. 2 divided by 7. Yes, 2 divided by 7. So agree, sir, agreeing, no issue as such. In the same sequence, let me take the next question. What it has been. Both balls are to be different colored. Anyways, before getting the precise most answer, try to figure it out what are the different sequences would come under this question. I want both of the colors to be different. That means neither can be blue together, neither can be black together, neither can be red together. Yes. So may I know what's going to be the situation over here? So here's going to be, see, the first can be black, the second can be red. Yes. Now even their sequence should also be taken in reverse manner. So it has been black then red, and here the red then black should come over here. But what we are going to do over here, both would have the same probability, and hence it has been multiplied with 2. Could you understand what I am saying? If you want, you can write. I don't have any problem at all. But what I expect, the student who have been following me, they should also reduce the number of steps, and they should be able to get the answers in compare with the others much early. Agreed? Similarly, OR. Here the OR would come. Now instead the black and red, if I have taken the pair of red and let's take blue. Here also the sequence would come into the picture. The first ball, if it is picked up with the red, and the second ball which has been picked up if it is blue, or if the reverse is being the sequence, it's going to make the 2 different scenarios. Anyways, once we'll add them together, definitely the 2 is going to get multiplied. And similarly, the same thing would go with 2 times of blue and black. So the student who had a little bit problem where the multiplication would be applied, where the addition would applied, obviously they can thought the complete problem in a form of English sentence, black and red. That looks okay. That is why the multiplication is going to come, or red and black, or black and blue, and their sequence would also come into the picture. That is why the 2 is overall getting multiplied. Yes. Okay. None of them are black. Certain mistake had been happened probably. None of them are black. Still few of the concepts is being left out. Still few of the concepts are being left out. Sorry. I thought, you can change it. No, you can change it. None of them are black. So still few more sequences are to get added. Like you can take the reference of R and black and blue. Those things can also be taken. Certain mistake has been happened over here. So this calculation which we have done it over here, no, the first problem, the calculation which we have done it over here. What was the question? None of them are black. None of them are black. That means either the first selection, either the second selection, neither of them should be black. Neither of them should be black. Yes. Sir, I tried this method. It is yielding 2/7. We'll see where the mistake you have done. May I know what should be the answer over here? You can do it by yourself. So what's happening over here? 2 had been the common in all of 3 terms. So why don't we bring 2 outside? May I know the first ball has been black. What would be its probability? 3 number of black balls you had out of 7 number of balls. That's fine, sir. And here it had been, the number of ball has been reduced to 6 because 1 ball has been taken out and has been discarded. Number of red ball which has been left out, my dear friends, only black ball has been taken out. So still the number of red ball which has been left out is being 2. Similarly, here it becomes, how much it would be? It would be 2 divided by 7 into 2 divided by 6 plus of 2 into 2 is already been taken out now, so I don't have to take 2. That's again, and number of blue balls what we had, black balls we had the 3 out of 7, and here it becomes 2 divided by 6. So the answer which you would be getting after doing this all calculation would be there in front of you once you'll do all of the calculations. Anyways, as far as the denominator are being concerned, they were common. So what you can do while doing the calculation, no, at least 7 into 6 can be brought it out. Anything else has been the common factor? Yes, sir, it had been. May I know what? The 2 was a common factor over here. It was over here. It was over here. So what you can do, the 2 can be taken as a common factor together. So the factor which has been left out had been 3 over here. 3 plus of 2, that's a 5. 5 plus 3, that had been 8 over here. The 5 plus of 3 had been a 8 over here. So what's happening? Just try to understand in this way. So here it becomes 2 4 ja, 2 3 ja, 2 3 ja. So here it becomes 4 into 2, that's a 8 into 2, that's a 16. 16 divided by 7 into 3, that's a 21. So would like to ask from each one of you, till this point each and everything is clear or not? So the 2 students have got trapped in the first question, probably the question number 1.2.4. They are getting the different answer. I will tell you where you guys are doing mistake. Yes. So probably the two students have got stuck while doing the calculation, Nishant as well as Aniket. So definitely I am going to repeat once again. See what mistake you guys would have done. See, I know that. What mistake you guys would have done. None of them are black. The people could have done, or people could have calculated this as 1 minus both as black. So they would have used the method of complement, but this would not work. Why? 1 minus both have been black. What does that mean of it? That means both have not been black. If both have not been black, what does that mean of it? That means both could be red, both could be blue. They could be black and red. They can be blue and black. Could you understand what I am saying? I know many of the students would also calculate in this fashion, but they would do mistake. They would do mistake. What they would do, just to smash this problem into the simpler form, they would calculate the probability that the both of the balls are black, and whatever the probability they get, they would subtract with 1. May I know what does that mean of it? That means both of them has not been black. What does that mean of it? Both of them has not been black. What does that mean of it? That means the one could be black, the second could be blue. One could be black, the second could be red. Both can be red, both can be blue. Both can be blue. Could you understand what I am saying? So the student who have calculated the answer with this method, they have done the mistake. They have done the mistake. Nishant and Aniket wanted to ask whether you have calculated the answer for this particular problem with this method alone or not, because this method would not survive. This method would not be the correct method. This method would not be the correct method. Here none of them are black. No, here you are saying both of them are not black. If both of them are not black, you are including so many unwanted conditions. Aniket and Nishant, I would like to have the input from each one of you. I would like to have the input from each one of you. Aniket, yes sir, I have mistake. I had mistake, yes. This mistake you people have done. So if you'll think the answer which we are going to lead by doing this all mathematical calculation and the answer which I would lead by doing this mathematical expression, would it be same? Utterly it would be different, because you have been doing the two different calculations. If you do the calculation, this calculation, no, may I know what are the different conditions you are encountering? Anything except BB. Anything except BB. Could you understand? Anything except BB. That means what are the different formulations you have been using? You are taking RR in account. You are taking blue in account. You are taking RB in account. You are taking BR in account. You are taking blue L and B in account. You are taking B and BL in account. You are taking everything except BB. Except BB. So यही जानना चाह रहा हूँ निशांत and Aniket. Probably you have followed this method, and this method is gonna be a flawed method, at least for this problem. Because if you say 1 minus of BB, that means except BB, all of the conditions, all of the events has been taken as a favorable event. So except BB, what are the different sequences you had? No, they all have been clubbed together, and you would be getting this value, which would be a very high probable value. Which would be a very high probable value. Agreed, no? So nobody should do this sort of mistake, because I have seen this has been a very common point of mistake. It's not the mistake which has been done by the Nishant. It's not the mistake which has been done by the Aniket. This is a mistake where most of the students found themselves very difficult. Yes. Let me take the next one. Both balls are same colored. Both balls are same colored. May I know what would be the answer for this given problem? It's quite easy, no? Both could be red. Both could be black, or both could be black, or both could be blue. And here the sequence would not come into the picture until and unless you are not withdrawing the two different color. How the sequence would come into the picture? No. Yes. May I know what does that mean by the R and R? How many red balls you had, my dear friends? The two number of red balls you had. So the number of way, the one red ball would be selected out of 7 number of balls. Out of 7 number of balls, the 2 number of red balls we had. 2C1 divided by 7C1, that's fine, sir. Now, if that ball has been taken and it's been discarded, so the number of balls which has been left out is merely 6. And similarly, the number of red ball which has been left out has been 1. And the number of red ball we had, the number of black balls we had, they are pretty same. So obviously, their worth would be very same. So the 2 would get multiplied. 2 would get multiplied. Sir, please take the problem with prefix in statement, at least, and at most. These are also confusing. We'll do now. We'll do. See, I have planned the mathematics for you guys, and probably you guys must be watching my AMFT classes also. I know what are the different points where my students are going to get stuck. I have definitely going to plan those all. May I know what should be the answer? You can do by yourself. Anyways, the probability of RR and BL has been added together, has been 2. And in case of black and black, you would start with 3 out of 7 and you'll reach to 2 out of 7. You'll get the answer out of it. You'll get the answer out of it. You would get the answer out of it. May I know from this prospects how many questions we have taken? 1, 2, 3, 4, 5, 6. Is that part clear to all of us? Is that part clear to all of us? If it is clear, definitely now we are going to go ahead with the next segment of the problem. May I know which kind of the problem we are going to take? Is still the number of balls would be 7, is still the number of black balls would be 3, blue balls would be 2, red balls would be 2, but the method of withdrawal has been changed. At the first segment of the problem, for the first chunk of the problem, we were withdrawing it together. We have taken in the last video. In this particular segment of 6 number of questions, we were withdrawing one after another, but after withdrawal, the replacement has not been done. It has been simply discarded. It has been simply discarded. In the same sequence, now comes the second or the third kind of the problem, and you can see this problem is comparatively easy problem. This problem is comparatively easy problem. Anyways, try to read this problem completely, and then we will try to decode how had been the change which we have been done it into the 2 different segments. A bag contains a 7 number of balls, forget about 3 and 4, are black 2 and blue 2, okay. Just a minute. So here certain mistake has been happened. Out of 3 are black, 2 are blue and 2 are red. That means as far as the configuration of the box is being concerned, no change. It's still 7 number of balls, and still the number of balls were same. 3 from the black, 2 from the red and 2 from the blue. No change. No change. Yes. Now the concept of the problem has been changed a bit. If 2 balls are withdrawn one after another with replacement, that means 1 ball has been withdrawn, you have noticed its color, and rather discarding it, you are just putting it back. And again you are mixing it properly. Either again you are just making a proper mix, and again you are picking another problem. So the 3 different ways of the problem you can have whenever the selection or the withdrawal takes place. There used to be the 3 different ways for that. First together, second one after another without replacement, and third one after another with replacement. So we have come into the third case. Here goes both are black. May I know what should be the situation over here? Both are black. That means I want the first to be black and I want the second also to be black. Anyways, once we would take the first ball out, and what's going to be the probability that the ball would be black? Out of 7 number of balls, how many black balls we had, my dear friends? The 3 number of black balls we had. And obviously because we want the first ball to be black and the second withdrawal, the second ball to also be the black only. And whenever the and do come, definitely the multiplication would come. That's for sure. That's fine, sir. Now what is happening over here, my dear friends? That the ball, in last 6 to 7 number of problems which we have taken, we were just discarding, but now that ball has to again come back to the box. That means there had not been any reduction of the ball, either in total number of balls, either in the black balls. Could you understand what I am saying? So here again, the number of balls which were there has been brought back to 7, and the number of black balls we had has been brought to the 3. So may I know what would be the answer over here? It's simply going to be 3 divided by 7, which would be raised to the power of 2. So I don't find till this point any of the student would have any sort of doubt now. Both are red. Yeah, it's a piece of cake. I don't find the student who have been following me since maybe last 2 hours, they would not be able to get this answer. My dear friends, both are to be red. What does that mean of it? That means the first ball has to be red. How many red balls we had? The 2 number of red balls we had. Out of 7 number of balls, how many ways it could have been selected? What would be its probability? It's going to be 2 divided by 7. 2 divided by 7. Now what's happening over here? That ball has been seen and again has been put back on our box. So still the number of red ball had been 2, still the total number of balls has been 7. So here again I am willing to get the red ball in the next trial. That has been 2 divided by 7 divided by 2 divided by 7, which would be leading as 4 divided by 49. 4 divided by 49. This must be clear to all of us. In the same sequence, 1 black and 1 red. See, they were just focusing over the quantities, that how many number of red balls we had to have, how many number of black balls we had to have. But the sequence do also come into the picture. If you are focusing over the requirement of this problem, whatever you do, the one ball has to be black and the another ball has to be a red. How it's possible? If you have withdrawn one ball, let's take that ball had been black and you wanted the second ball to be red. Or if you have withdrawn the first ball that has been found as a red and now you are in search of the second ball as a black. Second ball as a black. And again the same thing is happening, whether you calculate B into R into B, they are going to lead the same value. So as this both of the terms has been same, their worth had been same, so once you add them together, the two had been a multiplier factor, and just focus over the calculation of one. How many ways the black ball could be selected out of 7 number of balls? Out of 7 number of balls, 3 different ways the black ball could have been selected, because the number of black balls had been 3. If you're not able to understand, just think this as a 3C1 and just think this as a 7C1. Just think this as a 7C1. Now what is happening over here? Again that black ball has been observed and it has been put it back within the box. That means the nature of the box has not been changed. It's still the number of balls which are there within the box has been 7, and similarly the number of red ball, anyways, it is not going to change. So it's gonna be 2. So end of the day, the result which we are supposed to get, 2, it's 2 into 2, that's a 4, 4 3 are 12. Here it becomes 12 divided by 7 into 7 is going to be 49. Yes, so the 12 divided by 49 is going to be the precise most answer for this given problem. 12 divided by 49 has been the precise most answer for this given problem. In the same sequence, let me move forward. And 3 more remaining problem we are going to smash now. None of them are black. None of them are black. Again the same problem has to be there, and the same methodology 2 people were using should not be used. If you're using those methodology, definitely you would be leading the wrong answer. None of them are black. That means you can make any sort of combination, but either the first withdrawal or the second withdrawal, none of the ball has to be black. So may you know how many ways it could have been done? How many ways it could have been done? You have started with red and blue, or blue and red. Anyways, the sequence would always be mattering over here. Or both could be blue and blue, or both could be red, or you can just smash, or you can just add all of the different possibilities which has been set by this problem. None of them should be black. So we have started with making the combination between red and black. So obviously it's going to be RBL. If you want, you can write, otherwise you can just multiply with 2. That's fine, sir. Red and black is being done, black and black is being done, red and red is being done, red and red is being done. Anything else been left out? Anything else been left out? Tell me. Anything else is being left out? No. Nothing is being left out. Try to get its answer. One thing is quite sure. R into BL and BL into R would lead the same value. So why don't we add them together? 2 has been taken as a common factor. Out of 7 number of ball, the 1 ball has been picked out. What's the probability that the color would be red? How many number of red balls you had? 2 out of 7 into. Again that ball has been put in back. That means the number of balls still remains 7, and now we are in search with black. So here it becomes 2 into 2 divided by 7 into 3 divided by 7. 3 divided by 7. In the same sequence, what we are going to do, you yourself would be able to understand the black into black plus of red into red. Both of the terms would lead the same values. So again, the 2 had been taken common. May I know what would be the worth of black? That would be 2 divided by 7. Sorry, what had been the worth of blue and blue? 1 ball has been withdrawn. What's the probability that the ball would be blue? That is going to be 2 divided by 7. And what had happened afterwards? The same ball has been fed in back. That means there has not been any reduction in the total number of balls. There had not been any reduction over the total number of blue balls. So it has been 2 divided by 7 into 2 divided by 7. So end of the day, you can write this as 4 divided by 49. 4 divided by 49. Yes. 4 divided by 49. Tell me how much answer we would be getting after doing this all masakkat and all. 49 had been a common factor anyways. The 7 has not been a common factor towards numerator side. Nothing is going to get crashed out. So 2 into 2, that's a 4. 4 into 3, that's a 12. 12 plus of 8. Just check it out whether we are getting the answer as 20 divided by 49 or something else. Something else. You can check it out. You can check it out. Is there any mistake somewhere? Is there any mistake somewhere? So it's gonna be 2 divided by 7 into 3 divided by 7. That's gonna be 2, 2, 2, 2, 2, 2, 2, 2, 2. Perfect, no? Probably it's coming. Sir, please first term. I didn't get your answer actually. Please first term. This one you are saying. What I am saying, none of them has to be black. So the possibility could have been the first ball which you have retrieved had been red and it has been followed by blue, or the first ball was blue and it has been followed by the red. So obviously these are going to make the two different scenarios. You had to add their values together, although their answers would be very same. So that's the point where the student are doing mistake. So here the 2 would also get multiplied. So it becomes 2 into 2, that's a 4. 4 into 3, that's a 12. 12 plus 8, that's a 20. 20 divided by 49 probably. 20 divided by 49 probably. Yes, no? Both balls are different colored. And similarly, both balls are same colored. As far as both balls to be same colored, both could be red and red, or both could be black and black, or both could be black and black. Yes. May I know what is the possibility that the first ball which has been withdrawn would be red? That's gonna be 2 divided by 7, and again it would be 2 divided by 7, which would be raised to the power of 2. Keep in mind the worth which we would be getting over here and the worth which we would be getting over here, it's gonna be same. Why same? Because the number of blue balls as well as the number of red balls were same in count. Okay. Their mistake has been happened. So basically I was confused between blue and black. So the BL stands for blue, no? So obviously it would be 2 only. So here it becomes 2 into 2, that's a 4 into 2, that's a 8. So what are the difference we would be experiencing over here? So here it becomes 8. 8 plus 8 is gonna be 16 over here. So the result which have come in our hand is being 16 divided by 49. And similarly here it's gonna be 3 divided by 7, which should be raised to the power of 2. Anyways, if we'll take its LCM, both would have the same LCM, which has been 49. And if we'll talk about numerator, 2 has been raised to the power of 2, that's a 4 is getting multiplied with 2, that's a 8. And here 3 to the power of 2, that's a 9. Put together it's gonna be 9 plus 8, that's a 17. 17 has been divided with 49. So that's gonna be the probability of this. So would like to ask from each one of you, can I say you would be able to smash any sort of problem related to the permutation and combination, specifically in probability? I would like to ask from each one of you, would you be able to tackle all sort of the problem based on the concept of the probability which has been based on concept of permutation and combination? Yes or no? Because only 3 different kinds of the problems can be framed. All 3 segments has been elaborated by such a huge number of problems, and I have given such a huge number of time just to frame this problem for you guys. We are putting our complete effort. Yes, that is for sure. You won't get this systematic problem anywhere. And what happens, I have seen, if you learn the new concept from the each and the individual problem, no, and if the concepts are not coherent, usually you do not grab any of the important concept out of this. That is why I have taken almost semantic type of problem. We had a little differences in each and individual problems, and I have covered all of the 3 differences kind of the problems. First together, second one after another without replacement, third one after another with replacement. And one thing, the student who have been attending my EMFT, from today onwards it has been a complete paid course. So probably the student who have not been the student of our paid course would not be able to watch our today's video. Anyways, few more number of questions has been designed based on the concept of the permutation and combination. Today is not the right time. Yes, sir. Positively all you. Yes. Anyways, today we are going to stop our video here itself because I need to take the next class also from 10:30 onwards. Anyways, the student who have been enrolled for the electromagnetic field theory electronics, they can come on our application exactly at 10:30. So this is all about the important problems or the important set of the problems based on the concept of the probability, which uses the permutation and combination in backup. The video which were taken in today's class and the video which we were discussing in the last class, almost all of the questions were based on the concept of the permutation. Yes, together one after another, with replacement, without replacement, but the concept, the Gun concept which we were using, they were based on the concept of the combination. But for specifically tomorrow class, I have designed few number of questions, and there we would see when the concept of the probability should be exploited within the permutation. Yes, this all were the questions from the probability where the combination concept is being used, and tomorrow we would see few number of problems which are again based on the concept of probability, but there permutation would be used, because I have seen many of the times the student do have the doubt, sir, this problem should I be using the concept of the permutation or should I be using the concept of combination? So those part of the doubt you are going to get smashed in tomorrow's class. Okay then, bye bye, take care, good night.